and go to questions. I got one from Miss Circe. This is 6.445/11. And the reason I like this question is because it's a test question. And if you can do this question, you can pretty much handle 6.4 because this one has everything in it. So let's go ahead and do that. And I went and bought me some pens. Aren't y'all proud of me? Hold on. Bought me some pens. Dang old. Had to go buy some new pens for y'all. Aren't y'all?
Pretty colors.
Huh? I know. I love my neon colors. I love those. And the other colors, you know, I have this box, and I have another box of brand new ones. Here's the other box I got from Amazon. They just don't have the Sharpie name on them. I've got two brand new boxes, but I have to buy the neons and I have to buy the black ones because the last time I ordered a box of black ones, I did go through it, but I just hadn't had a chance to order another box. So on Amazon, they're a whole lot cheaper. All right, here we go.
Is that a tax write-off?
I don't know. I guess I could write it off. I just didn't think about it. I mean, I guess I could write it off. But I'm not a very tax person. I do what when it comes, I put it in a BA envelope and I give it to the accountant and they take care of it. So I'm really not a tax evader. I don't take advantage of the tax laws. I should.
You claim farming though, right?
What?
You claim farming though, right?
Oh yeah, I do that, but that's a separate. I keep mine separate from the farm. So yes, I claim everything on farm: diesel fuel, parts, feed. Yeah, I do all that good stuff. All right.
I did that for years.
What?
I did that for years as a goat farmer.
Oh Lord! I'm gonna tell you something. I have done it all. I have fooled with all animals on the farm. And I wouldn't take anything for cows. Cows are the less maintenance of all 4 or 5. Horses, too much maintenance. Sheep and goats, too much maintenance.
They're sick
pigs,
animals.
You can't deal with pigs. You can't put them in a head gate. At least with sheep and you can't. There's too much wrestling involved with pigs. And you get a sow or a boar up 600-700 pounds, you can't do anything with them. Shoot them with a dart gun, that's about it. So I have, I'm 53, and I have just found out, I've just come to the conclusion in the last 2 years, that I'm gonna raise 2 things the rest of my life: cattle and hay, and that's it. I'm not gonna try anything else. I'm done.
I don't blame you.
Well, but each their own. All right. This one says the electrical resistance of wire varies directly as its length and inversely as its cross-sectional area, A. Okay, so boom. We know it's going to be direct and inverse. So direct, Y is equal to K times X. And inverse, Y is equal to K over X. Now what I'm going to do is, since this is 2 formulas, I'm going to bring in a third variable for this X right here so I can put it over, so I'm going to just call this W. So I'm going to rewrite mixture of these two. K is the same. So I'm going to say Y is equal to Kx over W. And this is an equation that mixes direct and inverse. So now I've done what I need to do. Now I need to exchange variables. So R is equal, K never changes, directly as the length, L, and inversely as A. And there is my first sentence. Now, remember me telling you that you have to change the variables first? Well, that's what we just did. Okay, so one, you got to figure out the formula that you're going to use, or the equation. Two, you got to exchange the variables. Three, they'll probably ask you to plug and chug. Three, why don't, hold on. Why is it shouldn't be cutting off my page. Why is it doing that? Hold on. Let me check my resolution. We've been having power outages. Did y'all have a power outage this morning? Anybody?
I didn't.
You did?
No, I didn't.
Well, we've had one this morning, and one was right between my classes, and I was late for my second class because my AT&T was still booting up. It takes it 15 minutes to boot up. So anyway, 4, you might have to a new formula, new equation. And that's what I just did right here. Okay, so this problem, we've done the formula. We figured out we had 2 formulas. That's what we had to do. We did that. Exchanged, we did that right here. And now we have a new equation. And now they're probably going to tell us to plug and chug. So let's look at it says, and I'm going to mark this out right here. You mark that out because we're done. We're done with that. So you can mark that out. And the more you mark out on a word problem, the what? Y'all supposed to fill in. The better.
The easier it gets, the better.
Makes it easier, yes. The more you can mark out. So if you had this on a test, you could take your black marker and you could mark through that. And that's done. Okay, now, if the resistance of a wire is 0.4, so I'm going to go to my handy dandy. Okay, if the resistance R, if R is 0.4, we're plugging and chugging, equals, they probably want you to find K, so we're not going to worry about K. When it's length is L, 400, divided by, and its cross section is 0.05. We just plugged and chugged. So now we can take that sentence out. So we're done with those 2 sentences. Now, part 6 or part 5. They're going to want you to find K after you plug and chug. 6, write new equation. Sorry, hold on. 6, new equation with K. And then 7, you're going to do new info. So we're right here with the new equation and plugging and chugging. So it looks like to me, we're going to find K here. So what do we do? Well, first of all, we've got to multiply both sides by 0.05. So I'm going to take my handy dandy calculator and I'm going to multiply 0.4 times 0.05. Now I'm going to take my pink and I'm going to multiply this side by 0.05. And I'm going to multiply this side by 0.05. And that's going to take that out. And 0.05 times 0.4. Now I could have done that in my head because I know that 10% of 0.05, I know it was a 0.005, so that'd be 0.020. So you could do it in your head. If you don't mess up the calculator, you can do it there too. 0.05 times 0.4. 0.020. That's what I said. 0.020.
New Facebook comment.
0.020 is equal to 400 times K. I have some people mad at me because I defriended them this morning. I defriended about 4 or 5 people this morning. And I'm going to divide that by 400. And that's going to be 4 zeros and a 5. So 0.00005 is equal to K. Now I'm going to highlight that, and I'm going to sit where you can see it. There we go. I'm going to highlight that in yellow and pink because that is very important. Because what are we going to do with that K now?
Plug and chug.
Plug it back into this equation right here. You're right. So I'm going to take that, and that's where I get new what? I get my new equation with what? With K. And that's going to give me R is equal to 0.00005 times L divided by A. And that's my new equation with K. And now I'm going to do number 7 or 6 or 7. That's 7. Sorry. What's the only thing that I haven't marked through on the question? Somebody tell me. I marked through that 0.05 inch squared, so just ignore that. What's left?
The resistance of a wire, length
Okay,
3,000 feet.
What's this right here?
Length.
So we got L.
Yeah.
And we got A. So what are we going to do with L and A?
Plug them in.
Plug them in. So here we go. R is equal to 0.00005 times L is 3,000 over, over, and they say A is 400. Now you could actually cancel out this 0 and this 0 with this 0 and this 0 and get 30 over 4. And you could do it that way if you wanted to, saying you could. But we're going to go ahead and multiply 0.00005 times 3,000 and divide that by 400. So our resistance is equal to, well, that's going to be 3 zeros. 1, 2, 3, 4. 3 zeros, 375. And that is your answer. Now we're going to do this again because, like I said, if you can do this problem, you can do pretty much 6.4. So we're going to do another one, and that way you'll have 2 in your notebook, handy dandy notebook. So R is equal to KL over A. We got that with our right here, just to show you. I'll take my, I don't like to use the blue marker, but I'm not going to use I'm just going to circle it. So here's our first answer. And they will do this. Ask you for the equation. So read the questions. Here they gave you multiple choice, but sometimes they won't do that. Sometimes they'll say, what is the variation equation? And you're typing in 00375, and this, you're going to get it wrong, and they're asking for this. Okay, so make sure you read the equation or read the directions carefully. And my R is going to be equal to, says type as integer or decimal, 0.000375. And there's probably a rounding. So let's see. I don't know how they got that. I really don't know how they got that. Wait a minute. Oh, shoot. I put that in, and it's supposed to be 0.02. Don't you say it. I know somebody's fixing to say, well, I thought that's what, I figured it out. I had my thing up like this, and I thought that A was 400. See, right there. A is not 400. A is 0.02. Dork. So let's change that to 0.02. My bad. 0.02. And that's the only thing we got to change. So let's go back to our calculator. And 0.00005 times 3,000 equals divided by 0.02. There we go. My bad. But y'all saw that before I saw it, didn't you? Y'all knew what was wrong. So 7.5 is your answer. Now, they could ask for this answer. They could ask for K. Remember the 3 or 4 type questions I told you they would be asking? There's one question. Find the equation. Find K. What is the new equation? What is K, or what is R? Okay, so there's 4 test questions I could ask you right there. Does everybody understand that? Okay, I gave you, there's 4 type questions I gave you last week or Wednesday. And I said you're either going to find the equation, or you're going to find K, or you're going to give me a new equation with K, or you're going to give me the answer with new information. And the new information is what they gave us right here. What is the resistance of the wire with the length 3,000 and the area 0.02? And just don't think that's 400 and type in the wrong one. All right, so y'all go to it. I'm going to hit new question, and y'all do this one. I'm going to give you 3 minutes. On the timer, 3 minutes. Miss Hatton, is 3 minutes enough time for you?
New Facebook
I guess.
comment.
We'll see.
All right, I'm gonna give you 3 minutes. Starting now. Thank you, son.
I gave you the biggest piece.
Thank you. All right, that's 3 minutes. There's what we got. Y is equal to K, so I'm going to change. And it's the same thing. R is equal to K times L over A. And they give us 0.225 is equal to K times 300 over 0.04. So to find my K, I'm going to multiply both sides by 0.04. And that's going to give me really 0.04 times 0.225. 0.009 is equal to K times 300. Divide by 300. Divide by 300. And you should come out with K is equal to 4 zeros and a 3. Now we're going to take our green pen and we're going to back substitute this guy. Right there. And that's going to give us a new equation. R is equal to 0.00003 times L over A. And now they give us new information. What is the resistance? 0.00003 with a length of 6,000 feet with a cross section of 0.02. Now, does anybody know, there's only 4 of y'all here today, but can y'all tell me what resistance is in a hose pipe or a electric? Because water and electricity has very similarities. They all follow the path of least resistance, but they all have resistance. So what does the resistance mean in a cable? Anybody?
Pressure?
Not pressure, that's with water, and that's what happens, that's what changes in a hose pipe. But what is resistance in a cable or a wire? Basically, what happens to the electricity the further you go through a big cable? If it's a big cable, the electricity, does it increase or does it decrease?
Decrease.
It decreases, and that's what the resistance. The less resistance, the more the electricity gets through. Hold on just a second, please. Okay, so R is equal to, for this 6,000 foot cable, we're talking about, let's see, that's 0.003 times, and y'all should see, yeah, y'all do see my calculator. 6,000 divided by 0.02. 9. So that means that we have a resistance of 9 ohms. And that's a good bit because that's 6,000 feet of cable. 6,000 feet, 5,280 is that's a mile. A mile of cable has a resistance of 9 ohms. So and when there's no resistance, it's 0 ohms. So when you want to check to see if a line is broken, you put your positive cable on your, oh gosh, I can't think of the name of it, amp meter, on your ohm meter or whatever, and you put your positive end on the other end, and if it reads 0.0000, that means there's no break in the line. But if there's a resistance of anything above 0 on a wire, then that means something's wrong with the wire. The bigger the number, the more something's wrong with the wire. Now, when you're talking about 6,000 feet, a mile of cable, that's going to be minute, but once it gets to a certain point, the cable starts to lose its effectiveness. In other words, you got to put a junction box or something to get that electricity stored up to go to the next mile or whatever, or a transformer. Okay, because you're losing too much at a certain distance. So that's what resistance is. Okay, so that takes care of that, and that's both of those are good test questions. Now, I've got 15 minutes to go over a little bit of what we're going to go over. And now, 6.5 is not difficult. 6.5, there's 2 or 3 things that I'm going to write in red, and that means it's important or you're not going to understand it. Let me get this thing back up. 6.5, I don't have to take rolls, so I can go right to the last minute. 6.5 is on inequalities. Hold on just a second. My mother was calling to tell me 2 packages. I had my son call her, and so I wanted to make sure nothing was wrong. Okay, 6.5, inequalities. Here's what you've got to remember, and I might have told you this before. These 2 guys means that you're going to use parentheses. They also mean you're going to use an open circle, or if you're drawing a line on a 2-dimensional graph, it's a dashed line, and it's exclusive. That means you can't use the number that you have beside the inequality. You can't calculate. If it says x is less than 4, then you can't use 4. It's exclusive. And then these 2 guys means you're going to use brackets, a closed circle, and if you're graphing on a 2-dimensional graph, you're going to use a real dark, solid line, a little bit thicker than a regular line. And this is inclusive, meaning that you can use the number beside the inequality in the calculation. Now, what do you mean? Well, inequalities don't give us a solution. Inequalities give us a solution set. Yes, go get him. Sorry. The UPS man, we caught the UPS man out front. We got to give him a package. You know, out in the country, we do things different from in the city. Okay? We throw rocks at the UPS man to get him to slow down so we can give him a package. All right. So with that being said, let me gather my thoughts. I want to show you one more thing. Okay. Here is what a solution set is. A solution set, let's go with 6.1. Here's your problem from 6.1. X plus 3 is equal to 4. And you solve that and you went X is equal to 1. So you can take that solution, this is a solution, and you can plug it back in, and you get 1 plus 3 is equal to 4, and 4 is equal to 4. That is what we call a solution. And that's what you did. That's what you've been doing in 6.1 and 6.2. All right. Now let's do, and that one's getting dead, so I need to get another red pen. Now let's do a solution set. X plus 3 is greater than 4. Solve it the same way. Minus 3, minus 3. X is greater than 1. This is a solution set. Now, when you have a solution set, the first thing you do is graph it. Graph it on a number line. This is positive infinity. This is negative infinity. And 0 is right here. And we'll put a 1 right here and a negative 1 right here. Okay? Okay, now, this, we're going to put a open circle on 1. Okay, I'm trying to show you the association because I don't want you to say next class, Monday, well, how'd you know to use open circle? Well, because it's these two guys. Okay. Okay, so I'm going to put an open circle. And what numbers are greater than 1? These numbers. Everything to the right, including positive infinity. Now, there's two ways to write an answer with inequalities. And I'm going to put them in blue. I'm going to put them in another color. We'll go with green. One is called set builder notation. That's easy. You just put an X such that X is greater than 1, okay? And you put braces around it. That is set builder notation. So it's really not that big a deal. You just put a X such that and braces around it, and I'm not good with braces. And you put the answer right there. And then there's called interval notation. And interval notation, you just read the number line. Interval notation, parentheses, 1, comma, infinity. That's called interval notation. Now, what does this mean? Can I use 1 in this equation? No. Because if I use 1, that will be 4. Is 4 greater than 4? Yes or no? 4
No.
is not greater than 4. So you can't use 1. And that's why this is exclusive. Exclusive means you can't, that person's not invited. 1 is not invited to this solution. 2, we can plug in 2. Let me use a different color. 2, well, 2 plus 3 is greater than 4. Is 5 greater than 4? Yes. What about 6? Yes. Anything greater than 1 is the solution set. Okay, now, when you go home or over the weekend, I want you to make sure you go over this page that I just did on the video before you start any homework on 6.5, because you've got to get this down first before you move on. You've got to get this down. Let me get my handy dandy. I'm going to go with turquoise here. This right here, you have to put to memory. And this right here, after you get the solution set, you better make sure you can graph it on a number line, write it in set builder notation and an interval notation. Why didn't I highlight this? Because you know how to do this. You did this in 6.1. Now they're going to be more complicated. Okay. I've got 6 minutes and I've got time to go over another one. Okay, so let's go over another one. Now I'll do a little bit more on this one. So I'm going to do it in black because this is a problem. This is not, red is properties and things you should remember. This is going to be a 2 times 6x minus 2 is greater than or equal to x minus 6. That's good enough. Okay, so there's our problem. And I'm going to distribute. And that's going to give me 12x minus 4 is greater than or equal to x minus 6. And I'm going to bring that x across the river. And I'm going to bring that 4 across the river. And that's going to give me 11x is greater than to negative 6 plus 4 is negative 2. And x is greater than or equal to negative 2 over 11. So I'm going to graph that. That's positive infinity. This is negative infinity. Well, negative 2 over 11 is about 1/10. So I'm not going to worry about, making it. This is 0. This is 1, negative 1. This is positive 1. Negative 2/11 is around 1/10. So we'll put it right about here. And it's a closed circle, or some people in the book actually put a bracket. Okay, it'd be pointing the other way, sorry. What numbers are greater than negative 1/10 or 2/11? What numbers are greater than to the left or to the right? Greater means to the right. And that includes positive infinity. Now, the set builder notation you don't have to worry about. All you got to do is this. Braces x such that close braces. And then take your answer and plug it in. So that's set builder notation. Interval notation, you have to read the number line. So bracket, negative 2/11 to infinity. And infinity always gets negative infinity and positive infinity. I'm going to write this in red. Negative infinity and positive infinity always get parentheses. Why? Well, tell me what positive, give me the number that represents positive infinity. There isn't one. So you never do touch it. So you can't tell me what it is. So that's why you put infinity and you put a parenthesis on it. Another thing, integers mean whole numbers. When the directions say integers, you have to use dots, not shaded lines. Okay? Because this represents fractions, decimals, and percents. A shaded line represents fractions, decimals, and percents. Not shaded. Because this gives us fractions, decimals, and whole numbers. A shade like this gives us fractions, decimals, and whole numbers. When the directions ask for integers, you can't use the shade. You have to use like dots on the numbers. So like this is a number line. And infinity cannot be infinity. It has to be dot, dot, dot. Oops, sorry. It has to be dot, dot, dot. So this is 1, this is 2, this is 3. You cannot use the shade when the directions say integers. Please make a note of that because you're going to see a homework question and the homework and the test, and it's going to talk about integers, and you're going to go down to the answer and you're going to look for a shade, and the shade is not going to be there. It's going to be in terms of whole numbers, which is dots. Okay. Now I'm going to shut her down. That's 2 questions. That's 2 pages of notes for 6.5. So that gives you enough to try to work on some, maybe, several, but it doesn't give you enough to finish 6.5 unless you've had it before. Okay, so I'm going to shut down. We've already done the attendance, and I'm going to shut down the recording, and y'all have a great weekend.